Okay, this is a short video explaining how to do the binary search homework that's given on the homework sheet. Um, you should already understand the concept of a binary search. We'll review it very quickly and then we'll step through the code, and the problems should be you dash checking or tracing through the code to perform a binary search on a specific value. The concept of a binary search uh, starts with the concept of a list of sorted numbers. One way we can search a list of sorted numbers is we could start at the first one. Let's say we were searching for the number 67. We can start at the first spot. Is that 67? No. We go to the next spot. Is that 67? No. Is that 67? No. Is that 67? No. Is that 67? No. That 67? No. That 67. We found it. We searched sequentially, and it took 1, 2, 3, 4, 5, 6, 7 comparisons to find the number 67. Well, how can we do that more efficiently? Well, we can do it more efficiently if we skip to the middle of the list, and since the list is of size 11, and I'll move this down so we can see, the list is of size 11, we can go to the middle of the list and we'll search the middle spot on the list. Here's the middle of the list. And is that 67? No, it's not 67. 67 is greater than 55. So we can eliminate spot 5, but we can also eliminate the whole bottom part of the list with one comparison. And now we know that the number that we're looking for has to be in spots 6 through 10. Then we can look at the middle of the list again. Is that 67? No, well, it's not that spot. 67 is less than that number, so we can eliminate half of the list again. And each comparison, we can eliminate half of the list. That's the concept of a binary search. So now let's step through the code that we have. First, n is equal to 11 because the size of the list is 11. And of course, the array is numbered 0 through 10. That's my 11 spots. We'll set, excuse me, see if we can move this up a little bit. Okay, we'll set low equal to 0 because when we start out searching, the lowest possible location that the number can be at is location 0. High is equal to n minus 1. N is 11. 11 minus 1 is 10, so high will be 10 because the highest numbered spot it could be in is 10. Then we have our while loop that's going to do our searching. While low is less than or equal to high, well, low is 0 and high is 10. That's true. We'll do the loop. Mid is equal to low plus high divided by 2. Well, high is 10. Low is 0. 0 plus 10 is 10 divided by 2 is 5. So the current middle of the list is 5. So now we'll check to see the number we're searching for is 67. So we'll check to see is 67 in the list. Okay, the value is 67, value we're searching for. If A sub mid, well, mid is 5. A sub 5, that's this location right here, is 55. So is 55 greater than 67? No, it isn't. So we'll go here, A sub mid, which is A sub 5, which is 55. If 55 less than 67, that's true. So low is equal to mid plus 1. So mid is 5. Move this up just a little bit. So low is going to be equal to 6. So what did we just do there? We just saw that the value that we're looking for, 67, is greater than 55. So it's not in spot 5, and it's not in any of the spots below spot 5. So we can eliminate all of those spots. So now we're only looking at spots 6 through 10. Okay, and since we satisfied this if statement. We're not going to do the else right here. Okay, so now we're at the end of the while loop. We come back up. Let's clear this off. So now low is 6 and high is 10. That's still true, so we still search the list again. Low is 6, high is 10. That's 16 divided by 2, which is 8. So now the new mid is 8. So we're going to look at spot 8. Is A sub mid greater than value? The value we're looking for is still 67. A sub mid is 86. Well, 86 is greater than 67. So what does that mean? First of all, it's not in spot 8, so we can eliminate spot 8. And it's not in any of the spots after 8. So we'll take high and make it equal to mid minus 1. Well, mid is 8. 8 minus 1 is 7. So the new high is 7. So now the lowest spot it could be in is spot 6. And the highest spot it could be in is spot 7. So now let's erase this and go around our loop again. Now low is 6, high is 7. 6 plus 7 is 13. 13 divided by 2, and remember this is integer arithmetic, so 13 divided by 2 is actually 6.5, but we'll truncate the fractional part, so mid would be equal to 6 because it's an integer value. And A sub 6 is 67. The value we're searching for is 67. Is 67 greater than 67? No, so we don't do that. Is 67 less than 67? No, so we don't do that. So if it's not greater than, it's not less than, it has to be equal. So we found the number that we're searching for, and we'll return that number in mid, which is the number 6. So the value returned is 6, and 6 is the location of the number we were looking for. And that's one execution of the binary search routine. Okay, and you can see down here, low started out to be 0, then it was 6. High started out to be 10, then it was 7. Mid was 5 was the first midpoint. 8 was the second midpoint. 6 was the third one. So the answers are right there. So can erase this. And so the homework problem is to continue to work the remaining problems here, keeping a track of the values of low, high, and mid, and the value returned. And this is the value that we're searching for. For some of the items, the number is in the list and we'll find it. And for other ones, it's not in the list. And if it's not in the list, what happens is eventually low gets to be greater than high, and we'll fall out the loop and we return a -1. If you have any questions, email me, and thanks a lot. Bye. Hello? Yes.
Hi, this is Tanisha with Bluehost. I just got your email.
Okay, sorry about that. I was making a little video for my class.
No, you're fine.
Okay, so